Hey guys, welcome back to today's online class. Good to have you back. So we'll continue our topic chemical. We'll continue our topic about chemical kinetics. In this video, we're going to look at what zero order reaction, first order reaction, and what second order reaction. I'm going to show you I'm going to show you the various equations or formulas in what zero order reaction, first order reaction, and second order reaction. Then I will teach you how you can solve problem with that. You get, so I want to solve a lot of problems. So what I want to do is to make sure you have your right material, then also with your calculator. As we move along in this class, make sure if you have any question, you will drop it at the comment section. And if this video is helpful, always give it a like that this video is helpful. So let's focus on what zero zero order reaction. Now, in a zero order what reaction, zero order what reaction. So look at what first, look at what zero order reaction. In Rate's law, maybe you have what A moving towards to the product. It's okay. Rate's law relates the rate of a reaction to the what concentration of the reactant raised by what coefficient. It's okay. So this S means what the order of the reaction. This one means what rates, the rate. This one means what rate constant. It's okay. Then this one means what concentration of what reactant. Now, why does that mean what order of what reaction? So order of reaction tells how what the concentration related to is what is related to what to the rate of the reaction. Do you get that? So if I talk about zero order reaction, that is my x is going to be what zero. Do you get that? So this is the word concept of when it comes to what zero order what reaction. And we have called the integrated rates law. In the integrated rates law, that's where you can what derive the formula for what rate of what reaction. So if I should write this place out and say x is equal to what zero. Now, one common question they normally ask when it comes to zero order reaction is this. Now, because it's zero order reaction, if you check the very well, rates is equal to k raised by a raised by what zero. Instead that, do you understand? Zero order reaction. So it said that in a zero order reaction, the concentration of the reactant do not have any effect on what on the rate of the reaction. Do you get that? Because if I say A, which was concentration of what of the reactant raised by zero, then by anything raised by zero is what is one, right? So you can say rate equals to what k, right? So what you want to put in mind is that in a zero order reaction, the rate of reaction do not depend on the concentration of the reactants. It's a common question you will see in the exam. They will normally ask, in what other reaction in which the rates do not depend on the concentration of the reactant is called zero order reaction. Because this thing here is that from the Rate's law, S equals to what zero, and you put zero here. Anything is for zero, no matter the value of this concentration of the reactant, is going to be one, right? So that rate equals to what the rate constant, the rate equals to what the rate constant. Now, in the integrated rates law, in the word integrated what rates law. Now, when you derive the equation, because I'm not going to talk about how we derive the word formula for what zero order reaction. What you want to put in mind is that what here we have A naught equals to what A T plus what K naught T. Very important. Is okay. So this is the formula. So this is the formula for what zero order reaction called the integrated what rates law. Now, what is A naught? A naught was what the initial concentration. Is okay. Now, AT is equal to what final concentration. Now, K naught equals to what? Rate constant. Rate constant. And T is what? Is time. You can say T equals to what? Time. It's okay. T is equals to what? Time. So depending on the question given to you, what use the what solve use this formula to what solve that problem. Do you get that? I want to solve a lot of problems. I want to solve a lot of problems. I want to teach you how you can what apply this formula in solving a lot of what problem. Now, before I proceed further here, now this one means what? Rate constant for what? Zero order reaction. So remember we're talking about zero order reaction, first order reaction, what second order reaction. So it's going to be K naught means what? Rate constant for what? First for zero, sorry, rate constant for what? Zero order reaction. K1 equals to what? Rate constant for what? First order reaction. K2 equals to what? Rate constant for what? Second order reaction. So if you also have K3, what? Rate constant for what? Third order what? Reaction. And each of these have their own unique units. Do you get that? Now, rate constant, the unit is not the same to this guy, it's not the same to this one here, it's not the same to this other one here. So, how do I get it here? So, we have a simple formula you can use to get the units of any rate constant. It's okay. We have a simple formula to get the unit of any rate constant, whether zero order reaction, first order reaction, or second order reaction. So, with that simple formula, you can get anything at all. So, what is the simple formula here? You have the rate constant with rate n k. Kn is equals to what? Concentration, which is called what? Molarity. 1 minus what? N per what? Per seconds. Please follow me close here. So going to be 1 minus n per seconds. Can you see that? So now this one is the rate constant. N means order of the reaction. Do you get that? So remember, capital letter N is also the same as mole per what? Dm cube. Also the same as mole per liter. You get? So if I'm talking about zero order reaction, zero order. So at zero order, that is my n is going to be what? 0, right? So if I should impute this thing here, that's going to be k naught, which k 0, right? Rate constant for what? Zero order reaction equals to, here I can say molarity 1 minus 0 per what? Seconds, right? 1 minus 0 is what? It's 0 is 1, right? So it's going to be k naught equals to what? Molarity raised by 1 per seconds, right? So then my k naught, my unit of k naught is going to be what? Mole per dm cube per seconds. So then the unit of rate constant for zero order reaction is what? Mole per dm cube per seconds. Do you understand? So now, by the time we get to our second order reaction, I want to tell you how to get K1. By the time we get to first order reaction, I want to show you how you can get K1 and K2 using what this simple formula here. So our focus first now is this what first is this first one which is called zero order reaction. Do you see that? So the rate constant which is what K naught equals to what? Mole per dm cube per seconds. Now the next thing we want to do now is what? Start solving problem under this. So that's what I'm going to look at now. Okay, now let's start solving problems or problem and start applying the formula in solving or tackling out this problem here. So the first one here, we still have more to go. We still have so many questions we are going to solve. Enough for you to what? To master this how to use zero order reaction formula to work calculate question. In a zero order reaction with a rate constant of what? 0.025 molarity per seconds. That is the what unit of what rate constant for zero order reaction. So solution, let us start solving the question. So solution, so that is my k naught is what? Is 0.025 molarity per what? Seconds. The initial concentration of A is 0.8, right? So that is my initial concentration is what 0.008 what molarity. Can you see that? Calculate the concentration of A after 15 seconds. So there is you are asked to calculate what final concentration when time is what is 15 seconds. Can you see that when time is what is 15 seconds here? Now, what you want to know, understand here is therefore write what the general what formula. It's okay. Now, this is what we're actually looking for. So if you input our value here, initial concentration of A is what 0.8. 0.8 equals to D what I'm looking for. AT plus what? Here we have 0.025 times what 15. You understand? So here we have we have to calculate 0.8 equals to what? AT plus 0.025 times 15. Here we have 0.375. So if she makes a solve formula here, AT equals to so 8 equals to what? 0.8 minus 0.375. So 0.8 minus 0.375. Here we have 0.425 molarity. Can you see that? So you can see how easy it is, right? Now, you can pause the video and try question 2 for me and see if you're going to get the answer. So pause the video and try question 2. Try and solve question 2 for me. Pause that video and solve question 2 for me. So if you look at question 2, they said in a zero order reaction, the rate constant. So here also have what rate constant to be what 0.02 molarity per seconds. The initial concentration, here we have initial concentration is what 1.5 what molarity. Now, calculate the time required for the concentration of A to decrease. So that my final concentration is okay, is what 0.5 what molarity. So they're asking you to calculate the time taking, right? So apply the formula here. A naught equals to what? A T plus what? K naught T, right? So if you input your values here, here we have 1.5 equals to what? 0.5 plus 0.02 times T, right? So if you should do your calculation here, we have T equals to 1.5 minus 0.5 over 0.02. What is the answer? So here we have 1.5 minus 0.5 divided by 0.02. Here we have 50. So remember, what is the unit? Here we have molarity per seconds. Here we have seconds. So you go to be seconds. That is what is the unit. Just so here we have 50 seconds. If you are following this video here, please leave it in the comment section that you're actually following this video and you're getting a lot of value. If you have anyone that want to be part of this class or watch this video, you can copy the link of this video here and share it to your friends, share it to your various departments. Don't forget to leave don't forget to leave any question you have at the comment section. So let's get to other question. Okay, now let's look at question. Let's look at question 3. Look at the question on the board. They say calculate the rate constant K for zero order reaction. And I will give you what this value here. You look at the time, look at what the concentration. So therefore, because it says zero order reaction, so I'm going to write it out. A naught equals to what? A T plus what? K naught T, right? Now, you can pick any one you want to use. You can see from 0 to 10 to 20 to 30. So now I have to pick from my initial time and my final time. Now, because here is going to be the initial, here is going to be final. Just that. So I can say T T1 is equals to what? 0 seconds. 0 seconds. Then T2 equals to what? My when you find time is what? 30 what seconds. Can you see that? Now, at 0 seconds, what is my concentration? So that concentration is going to be what? My initial concentration. So my initial time, we have what? Initial what concentration, which is 0.5 what molarity. Can you see that? Then my final time, we get what? My final concentration. It's okay. We're going to be what? 0.2 what molarity. Just that. Now, remember, here I have this time here, right? So if I say the total time here, we can say time equals to what? T2 minus what? T1. Because I can't use what? Both time, right? So it's going to be T2 minus what? T1. So now, if I want to do that here, so it's going to be 30 seconds minus what? 0 seconds. What does that mean time? 30 what? Seconds. Can you see that? So this is what I'm going to use now. So it means that my time is what? 30 what? Seconds. This is that. So now let's start imputing our values. So my initial time, my initial concentration is what? 0.5, right? Equals to what? My final concentration is what? Is 0.2 plus. Now remember I'm moving for K naught, right? Times 30 seconds. Times 30 seconds here. Can you go to this other side? Here we have 0.5 minus 0.2 equals to what? 30 times which 30 K naught, right? So if you should do the calculation here, K naught equals to what? 0.5 minus 0.2 over what? 30. What will be the answer? So it's going to be 0.5 minus 0.5 minus 0.2 divided by 30. So it will be 0.01. Is it okay? So it's going to be 0.01. But what is it of K naught? Remember the unit of K naught, because we are talking about zero that reaction, is going to be what? Mole per dm cube per what? Seconds. Can you see that? That is the answer. Now remember, the rate constant must be constant irrespective of the values you choose. You understand? So yeah, when I use 0 seconds and 30 seconds, I got 0.01 mole per dm per seconds. Now you'll be asking, what about if what about if you should use 10 and 20? Are we going to get the same answer? The question is yes. Or if I should use 10 and 30, am I going to get the answer? Am I going to get the same answer? Yes. If I use 20 and 30, am I going to get the same answer? Yes. It's going to be constant. So let's prove it if you are still going to get the same answer here. So now I want to use 10 and 20. Let me see if I want to get the same answer. So it will be T1 equals to what? 10 seconds, right? And T2 equals to what? 20 what? Seconds. Now remember, T1 is what is my initial time, right? So yeah, for me I'm going to get what? Initial what? Concentration. Now T2 is what? My final time. So I want to get what? Final what? Concentration. So at 10 seconds, what is the concentration? What is the concentration? Is what? 0.4 molarity. Now at 20 seconds, what is my concentration? Is what? 0.3 what? Molarity, right? Now I want to calculate what my time. I'm going to be T2 minus what? T1. Can you see that? So if you should do that here, T2 minus T1. So it's going to be 20 seconds minus what? 10 what? Seconds. What are you going to get? It's going to be what? 10 seconds. So my time I'm using is going to be what? 10 what? Seconds. Can you see that? So now let's impute our values and get what? Our K. So it's going to be 0.4 molar. Okay, you should ignore so here. 0.4 equals to 0.3, right? Plus K naught times what? 10 seconds, right? Correct us, and here we have 0.4 minus 0.3 equals to what? 10 k naught. So if you make k naught the formula, if you make k naught the formula, you're going to be 0.4 minus 0.3 over what? 10. So let's see if you are going to get the same answer here. So here we have 0.4 minus 0.3 divided by what? 10. Here we have 0.01. 0.01 molarity per dm cube per what seconds. Can you see that? That is it. You can see that it's the same. If you should use this one here, you can use any more. It's still going to give you what the same answer because it's called the rate constant for what? Zero order what reaction. So that is for what? For zero order reaction. Now let's move to what? First order what reaction. First order what reaction. So we are also using A moving to what? To the what product. Right? A moves to the product. Now if you should write the integrated rate, now if you write what the rate law expression, so it's going to be rates equals to what? K A raised to what? X, right? Now because we are talking about first order reaction. First order reaction, so we're going to be S equals to what? 1. So we're going to be rates equals to what? K 1 A raised to what? 1 here. Do you see that? So this is what is the rate law expression when it comes to what? First order what reaction. Now, but when we talk about in the integrated what rate law, integrated rate law. In the integrated rate law, now when you want to derive the formula or the equation for first order reaction in the integrated what rate law, you have this here log A t equals to what? Minus k1 t, well, 2.303 plus what? Log A naught. Just so this is formula for what? First order what reaction. So it's being derived. So here we have log A naught, log of what? Final constitution equals to minus k1 t about 2.303 plus log what? A naught initial what? Concentration. Now you can also rewrite it and you are going to get something like this. I'm going to get log A naught over what? A t equals to what? K1 t over 2.303. It's okay. So out of these two equations or two formula, you can use anyone that suits you to solve problem. And I'm going to teach you how you can use to solve problem here. So these are what two formula I'm using for what when it comes to what first order what reaction. Now remember K1, what will be the unit of K1? I give you a formula to calculate to get the units. So which is what? Kn equals to what? Molarity, which is what? 1 minus n per what? Per seconds, right? Now we are talking about first order reaction. So remember n it means what? Order of the reaction. So if I'm talking about first order reaction, then my n is going to be what? 1. Right? So if I should plug this one here into this formula here, what am I going to get? I'm going to get K1 equals to what? 1 minus 1 per what? Seconds, right? 1 minus 1 is what? Is 0. So K1 equals to what? Raised to what? 0 per what? Seconds. Remember, n to raised to 0 is what? Is 1. So my unit of rate constant for first order reaction is what? Per what? Seconds. So this K1 is what? Is rate constant for what? First order reaction, which is going to be per what? Seconds. Do you understand? So these are stuff you actually what? Using in this calculation here. So let's solve like 2 or 3 or 4 problems relating to this. So let's do it. So let's look at what these 3 set of questions are. So here are the formulas here. I've set it up. So I'll be able to solve this problem here. They say you are conducting an experiment to study first order reaction. The initial concentration. So there's some question. What question 1? So the initial concentration, which was A naught, is what? Is 3.6 what molarity, right? and the reaction is allowed to proceed after 20 minutes. So time is what 20 what minutes. It's okay, 20 what minutes. The concentration of A has decreased to what 1.6 molarity. So here we have AT is equals to what uh 1.6 what molarity, right? Let's say calculate the rate constant. So you're looking at K1. Now, when you convert it to seconds, right? So 60 times 20. Remember, if you're converting minutes to what to seconds, you need to multiply by what 60, right? So it's going to be 20 times 60. Going to be what 1200 seconds. It's okay. That is it. So from here now, let's look at what you can easily use to solve the problem. You can use any of them. So you are the one that will decide to pick the one that is most suitable for you. To me, I want to use this guy. I want to use this one. It's okay. This is what I want to use. So if I should use this one here, so I want to use this guy here. So I will just say log A not about A T, right? So okay, I'm using this one here equals to what K1T about 2.303. So you are the one that will select the one you can want to make it of that most easier for you. Now the reason why I pick this one here is because I know my A naught, I know my A T. I can easily want take log of two of them. I easily want to make K1 the same formula. That is the reason why I'm using one here. So it's going to be log A naught is what 3.6 over what 8 is what 1.6, right? Equals to, remember I'm looking for what K1 times my T is what 1200, right? Over what 2.303. So what I want to do here, so what bring up my calculator. It's okay. So that these are I'm going to put because so many students don't actually know how to use calculator to solve this type of problem here. So when you have something like this, now this is your calculator, it's okay. And the calculator have log function. So how do you punch this one in the calculator? So it's going to be log. Open a bracket. It's okay. Open a bracket. There's a bracket here. Punch 3.6 divided by 1.6. It's okay. You have to get the answer. So it's going to be log. Open the bracket. 3.6 divided by 1.6, right? Close the bracket again. So you have 0.0.35218. It's okay. This one is okay. So you can express to what to at least 3 decimal points. It's okay. It's enough for you to get the answer. So yeah, I already have 1, 2, 3, 4, 5. So it's okay. Equals to K1 times 2 1200 over what 2.303. It's okay. So what I want to do here is to cross multiply. If I should cross multiply, yeah, if I should make k the same formula, it's going to be K1 equals to what 0.3235218 times 2.303 over what 1200. This is that. So my K1 equals to. So what I want to do is to use my calculator here. 0.35218 times 2.303. Now what I did here, I put this one in a bracket. It's okay. Divide by. So divide by 1200. So yeah, I would have 6.76 exponential what minus 4. That is it. So this is what my rate constant for this question here. So what is the unit for rate constant when it comes to what first order reaction? Of course, it's what per seconds. So it would be per seconds. It's okay. Now another thing is that what about if you leave it in minutes? If you leave it in minutes, that would be per minute. That is you think about this minutes or to seconds. So now let us say, for example, yeah, you use 20 minutes, right? So anyway, you see that one as 200, you put your okay, what I 200, you put what 20. So the final answer will now be what in minutes. Do you understand? So here we want to convert to seconds. So that one we have what per seconds. Do you understand? So I would like to go ahead, pause the video and solve question 2. Let me see what you are going to do. Now, what makes you a good student and what makes you an intelligent student that you're going to try is your ability to see a problem and be able to solve it. And this is what I used to tell my students that the easiest way to learn something is to actually do it. So that is why in my class, when I give you a question to solve, or when I solve a question, I would like you to want to try. The same thing, I want to replicate the same thing in this video, in this my online class. So I've done the first one, which I've actually explained the background. Do you understand? So pause the video, go ahead and try this question 2 for me. So just pause the video, try question 2 for me, then leave your answer at the comment section. But this question 2. Now, I believe you have actually what solved that question, right? So let's go question 2. In a first order reaction with a rate constant, rate constant of what? 0.03 per watt per second, right? The initial concentration of A, that is my initial, which was A naught, is what? Is 0.8 watts molarity, right? Calculate the concentration of A after 60 seconds. So concentration of A, so that was my final what? Concentration, right? Now, when the time is what? 60 what seconds. Like I said, you can either use this first one or you can use what the second one, depending on the one that is more easier for you. So yeah, I want to use the second one, the first one. It's going to be log A T equals what minus K1T about 2.303 plus log A naught. Can you see that? So from here now, I want to impute what my values. So log A T is equals to now minus here we have 0.03 times T is what 60 over 2.303 plus log A naught is what 0.8. Do you see that? So what I want to do here, I want to treat it as separate entities. Is it okay? So here we have what log A T equals what? Now what I want to do is to point this one here separately. So it will be 0.03 times 60 equals to then divided by 2.303. So it's going to be 0.03 times 60 divided by what? 2.303, right? So here I have what? Minus 0.7816, right? So here we have, it's already what? 4 decimal points. Okay, so now for accuracy, you can leave what 4 decimal points and above. Do you get that? For accuracy sake. Plus, now let's do what log 0.8. This plus here log 0.8. So we're going to be what minus 0.09691. Can you see that? So plus times minus is what minus. So here we have 0.7816. Now minus 0.09691. It's okay. So then I'm going to do what my log what's 80. Remember there is minus here, right? There is minus here. So we're going to be minus this. So I want to widen this place here because there is no other space again. So I want to widen this place out so that for me to be able to complete the calculation. For me to be able to complete what the calculation. So if I should do it here, it's going to be what? Log A T equals to minus this. So it's going to be minus 0.7816. 16 minus 0.09691. So here we have minus 0.87851. Can you see that? Now, here we have log, right? Here we have log. Now, our main aim is to what? To look for what? The constitution, final what constitution. So what we want to do here is what? Divide both sides by log. If you divide both sides by log, here we have log a t over what? Log, right? Equals to what? Minus 0.87851 over what? Log. So this becomes out this guy here. So here we have, let me write this thing out. So here we have a t equals to what? Now, this will also be written as 1 over what? Log, right? Times minus 0.87851. It's okay. Now, they are the same here. This one is called log inverse. Log inverse. It's okay. And log inverse is just now anti-log. Anti-log. So it's going to be a t equals to what? Anti-log minus 0.87851. It's okay. So what I want to do here, how do you get your anti-log using this calculator here? Now, there's always what a log, there's always what a log what, there's always what a log symbol here, right? Now, how do we get log inverse? You're going to be shift log. You probably shift here, then now press what log. You see 10. That 10 is what? Log inverse. So you now put this value here. So shift log, right? You see 10 like this, right? So from there now you can now put your answer minus 0.87851. So yeah, my final concentration now is 0.132 0.133 molarity. Just that. So it have decreased to this point. That is meaning. That is sign for question what 2. So what up here? You go ahead and try to from question 3. Leave your answer at the comment section. Solve question 3 for me. Leave your answer at the comment section. I want to see what you can do. I want to see what you can do. Leave your answer at the comment section. It's okay. So I want to see what you can do. Now, there's another difficult problem I want us to tackle before we move towards second order reaction. If this video is helpful, please leave me in the comment section that this video is helpful. I want to hear from you. And if you need this kind of content, always say you need this kind of content, the topic you want to learn in chemistry is giving you a headache. I will create a video on that. So, in case I've not told you, we are on our 30 days challenge for the month of October. We're creating videos every single day till the end. So every day on the channel, you should be expecting at least a video or 2 videos on a consistent basis. I promise you, we are able to achieve that this month. Do you get that? So now, make sure you try this one. Then we have to solve one more question before we move towards second order reaction. Okay, now we have this one on the board. This is a technical question, so you will have to pay close attention to what I'm about to teach you. It's that cyclobutane C4H10 decomposed at 1000 degrees centigrade to 2 moles of what? Acetylene C2H4 with a very high first order rate constant. So my rate constant, which is what K1, my K1 is what 87 per second, right? Now you say that, let me look at your first question. They said if the initial concentration of cyclobutane is 2 moles. Now, there's a problem here. It's supposed to be molarity. It's okay because concentration is not moles, right? So you have to what? Change that one here. So you're going to do what? Molarity. Molarity. It's okay. If the initial concentration of cyclobutane is what? 2 molarity. But in case you see it in here is that as mole, you have to use it like that. You understand? 2 molarity. What is the concentration after 0.01 seconds? Right? So now my time is what? 0.01 seconds, right? Now my initial concentration, which was A naught, is what? 2 molarity. So what I want to get here, They're asking us to what, calculate what the final what constitution. I believe you have done this before, right? So I have to use what the first equation here, the first formula here to get the answer. So it's going to be log a t here equals to what, minus 87 times t 0.01 over 2.303 plus log here we have 2. Can you see that? So it's just like what we have done previously. So it's going to be log at equals to. So it's going to be 87 times 0.01 divided by 2.303. So it's going to be minus 0.3778, right? That is it. Plus log 2 is what? 0.3010, right? 3. So if you should look at it very well, a c here equals to minus, so it would be minus 0.3778 plus 0.30103. So here we have minus 0.07677, right? So take the log inverse here, like what we have done here. A t equals to anti-log minus 0.07677, right? So let's see what we can do here. Shift log, right? Minus 0.07677. So we're going to be at equals to what? 0.838 what molarity. That is what my final what constitution. That is what for the A. Now look at what for the B. So I want to write space art. So guys, my at is what? 0.838 what molarity, right? Now look at what B. I said what fraction in percentage of cyclone is decomposed. The fraction, percentage fraction is very easy. It's okay. Percentage fraction is what? Is the initial constitution minus what? Final constitution over what? The initial what? Constitution times what? 100 over what? 1. So whenever they say what fraction of the reactant that decompose, this what you want to make use of. It's okay. This was simple formula I want making use of. So final minus initial divided by what? Final times 100 over what? 1. So it's going to be like this. So 2 at is what? Sorry, a naught is what? Is 2 minus 8 is what? 0.838 over what? 2 times 100 over what? 1. So let's use our calculator in solving this stuff here. 2 minus 0.838 divided by what? 2 times 100. Here we have percentage fraction. Percentage fraction is equal to what? 58.1%, right? That is it. So we have solved a lot of problem when it comes to what? Second or first order reaction. So let's look at what second order reaction. Let's look at second order reaction. Let's look at what second order reaction. So A move to what? To the product. To the what? Product. Now rate is equal to what? K A raised to what? X. So S is going to be what? 2 because we talk about second order what? Reaction, right? So it's going to be rate equals to what? K A raised to 2. So you derive what? The integrated what? Rate law. Now in the integrated rate law derivation, here we have 1 over what? A T 1 over what? A T equals to what? 1 over what? A naught plus K2T. So this is the formula you are actually going to what? Make use of when it comes to what? Second order what? Reaction. Now let's derive our unit for what? K2. It's okay. Let's derive for our unit for K2. Remember here we have K n equals to what? Capital letter M raised to 1 minus n, right? Capital letter N, molarity, 1 minus n per what seconds, right? So now, because we are talking about second order reaction, it means that my n is going to be what 2, right? So if my n equals to 2, if I should impute it there, so it will be k2 equals to what? Capital letter M 1 minus 2 per what? Per second. Can you see that? So 1 minus 2 is what? Minus 1. So it will be capital letter M minus 1 per what? Seconds. Is it okay? So in some textbook we see it as what? K2 is equal to what? Per molarity per what? Per seconds. It's okay. This one is what is acceptable. But what I want to understand is here is that remember molarity is always equal to what? Mole per what? Dm cube, right? So if you should substitute there, so here we have K2 equals to what? Here we have molarity minus 1, right? This one minus 1 per what? Seconds. So now let's increase this guy here. So here we have molarity per dm cube minus 1, right? Per what seconds. It's okay. Now, if you show me the bracket, remember here is minus 1, right? Here was minus 3, which is not showing. This is minus 1. So if you move here, you can move here, you see minus, you see what? 1. Right? So if you show me the bracket here, 1 times minus 1 is what? Minus 1. So it will be more raised by minus 1. Minus 3 times minus 1 is what? Is plus. So minus times minus is plus. So it will be 3. It's okay. So the unit of K2 is what? Per mole dm cube per what? Per second. So most times this is how you see it. Or you can say per molarity per what? Seconds. Okay, now let's tackle this question. Let's tackle this question. This is that for a second order reaction, the initial concentration of A is this. So it's 0 to 5. So my initial concentration A naught is what? 0.5 what? Molarity, right? After what? 20 seconds, it decreases to so my final concentration is what? 0.2 what? Molarity. So time is what? 20 what? Seconds, right? What they ask to look for the rate constant for the what? Reaction. So K2 is okay. So are we using 1 watt A T because what? 1 watt A naught plus what? K2T, right? So what you want to do here is picture what your value. So here we have 1 watt 0.2 0.2 equals to 1 watt 0.5 plus K2 times what? 20, right? So this is calculated to 1 divided by 0.2. 1 divided by 0.2. Here we have 5 equals to 1 divided by 0.5. Here we have 2 plus K2 times 20. Is okay. So 5 minus 2 equals to 20 K2, right? So K2 equals to what? 5 minus 2 over what? 20. You get your answer. So it will be 5 minus 2 divided by what? 20. Here we have my K2 is what? 0.15. Now what is units? Per molarity. Per molarity per what? Per seconds. So you go ahead and try number 2 for me. It's okay. Leave your answer at the comment section. So we have come to the end of this class. So this is day 1 of our 30-day challenge. So tomorrow we are going to have on that video here. But if you have not watched our previous video on if you have not watched our previous video on chemical kinetics here, you see it at the comment section. If this video is helpful, always give it a like. I beg, give it a like. Please give it a like. It's okay, and subscribe if I'm not subscribed. It's okay. It's just a way for you supporting this channel, and also invite your friends to be part of this online class. So this is just a way for me to help you understand chemistry faster and better. You get. So go ahead, click on the screen now to see the video you like to watch, or go to the comment section to watch what previous video or what chemical kinetics. See you tomorrow for the next class.